On the 11th of July, the world was left awestruck by the release of the vastest and deepest astronomical image ever acquired. It was captured by the James Webb Space Telescope, which is NASA's newest flagship observatory. The shining, sparkling diamonds in the dark we see are actually a myriad of galaxies of all shapes and sizes behind the galaxy cluster SMACS 0723. Continue watching to find out how this changed astronomy as we know it. But first, how did we come this far? To understand how we ended up here, how astronomers set sail to galactic islands so far away in time and space, and then collected photons whose journey began staggeringly close to the Big Bang. It's useful to know how deep field observations came to be. Some of these distant lighthouses we have seen lighting up since before the universe turned a few 100 million years old. That's blowing our minds. So what is the story behind deep field observation? The birth of Webb's first wide field telescope can be traced back to the early days of the 1990s. It was just then when the debut of the JWST's forerunner, the Hubble Space Telescope, took place. Deep field observations and their concept were still in their infant stages at the time. Hubble was mainly structured for targeted observations, in which the experts would steer the telescope to point to a source in a specific location in the sky and expose or integrate as necessary, depending on the brightness of the source. However, the Hubble telescope could be used for deep field imaging as well, but it has to be do quite the opposite. The astronomers were required to point the telescope to a region in the sky that lacked any visible sources and use a lengthy exposure time to reach into the depths of the cosmos to find as many subtle sources of light as possible. Hubble was the perfect platform for deep field imaging that astronomers had ever known. It was resting in low Earth orbit on top of our planet's starlight, scattering ocean of air. So it really just had to be the best there was. But that didn't mean there weren't any haters hating. There were. Despite all the cool stuff, not everyone expected the approach to be revolutionary. In 1990, John Bacall of the Institute for Advanced Studies and his colleagues tried to argue in a famous article published in Science that a deep field image from Hubble would not disclose substantially more galaxies than subsurface telescopes. Bacall, an astrophysics giant, was well known for solving the problem of solar neutrinos and calculating the dispersion of stars surrounding a massive black hole. From its conception in the 1970s to its launch, he made significant contributions to the Hubble Space Telescope's development. Despite his belief that Hubble Deep Field wouldn't uncover new galaxies, he prophesied that such photographs would aid in the study of the size and shape of hazy galaxies. He also predicted that the demography of quasars, a rather archaic term for accreting supermassive black holes. Now that big dreams of deep field imaging were stomped on, there was no rush to try it. Such skepticism dampened any desire to try deep field imaging with Hubble. The first endeavor didn't take place until near Christmas break of 1995, following a very much required optical repair. The telescope used up 10 days of exposure time peering at a small spot of the sky in the Ursa Major constellation. It was only 1/13 the angular diameter of the moon. When astronomers saw the resulting image, which was called the Deep Field North, weeks later, they came to know it was a Christmas gift of the century. The Milky Way stars are very scant in the target area, letting Hubble peer through a peephole into the cosmic netherworld. The telescope detected nearly 3,000 faint galaxies of various shapes and sizes, far more than anticipated, with some as far away as 12 billion light years. Hubble wasn't just exploring space, but was also observing time, collecting starlight which had been generated eons ago during earlier epochs of the universe. The image became popular very fast. It was legendary. But was the galaxy-rich image just a coincidence, or was it the norm? Hubble obtained the Deep Field South in 1998. The exposure was similar, but the telescope was pointed to the southern celestial hemisphere, as far away from the first spot as possible. And this new image validated that there were far more galaxies in the universe than previously believed, particularly at great distances. Along with their important scientific and uplifting worth, the Hubble Deep Fields depicted a challenging task, with over 10,000 galaxies comprising one of the very initial big data challenges faced by astronomers. Deep field imaging doesn't have to be limited to the visible spectrum. The world was fully prepared at the turn of the millennium for the first high-energy deep field, procured with the Chandra X-ray Observatory. And this was a groundbreaking NASA mission launched in July 1999, and it's still operational today. The Chandra Deep Field South was created by incorporating for nearly 1 million seconds over a section of the sky in the Lockman hole, a window free of hydrogen clouds and Milky Way dust. The revolutionary Chandra image revealed the extraordinary universe. And there were many hundreds of black holes, some very distant, that appeared in an image that was not as visually impressive as the Hubble photographs, but was dense with science. And the field was replicated once more with Chandra, with an overall exposure time of approximately 7 million seconds, making it the deepest X-ray field ever obtained. The Chandra Deep Field North, which contains data from over 500 X-ray sources, was released in 2003. And then came the Hubble Ultra Deep Field. The Hubble Ultra Deep Field was released in 2006, as an addition to Hubble's repertoire of the advanced camera for surveys. The historic shot included thousands of galaxies, some of which were later discovered to have been lighting up when the universe was younger than 1 billion years old. Practically a baby if you ask us. And the ultra-deep field revealed the background and story of galaxy formation in incredible detail. The distant galaxies seemed to be smaller and weirder in shape than the closer ones. This gave additional proof to support galaxy evolution theories. The ultra-deep field is basically the deepest picture that optical wavelengths can actually create. If a galaxy is too far away, its optical light is moved out of the visual spectrum and into the infrared regime. And this is due to a cosmological red shift, which occurs when the universe expands and extends out the wavelengths of light traveling through vast expanses of intergalactic space. To look further out in space and time, infrared camera was considered necessary. An infrared ultra-deep field was achieved in 2009 with the addition of almost infrared camera from Hubble. It revealed galaxies beaming only 600 million years after the Big Bang. That's like a very, very long time ago. After about 10 years in 2019, NASA's Spitzer Infrared Space Telescope released a deep field image. Both of those photographs are ideal for detecting galaxies at the dawn of time. Finally, Hubble's Frontier Fields campaign was at the forefront of deep field imaging, and this was like an appetizer to the main course, which was Webb's first deep image. Hubble was pointed toward the direction of 6 huge concentrations of galaxies during this exploratory campaign, which ended in 2017. According to Einstein's theory of general relativity, the existence of a substantial density of mass within the line of sight can bend and hence magnify the light flowing from a background source. This is an effect known as gravitational lensing. As a result, these galaxy clusters were made to use as magnifying glass to look even further away. The Frontier Fields photos are embellished with strange arcs of light, which represent the strained and enhanced images of background galaxies. They're much farther away than the cluster and potentially too faint to be identified by direct imaging with the Hubble. And these images revealed some of the universe's furthest away galaxies, as well as the first gravitationally lensed supernova. So what else has the Webb telescope caught? James Webb has also been able to capture a glimpse of Stephan's Quintet. This is a cluster of 5 galaxies that are colliding in the constellation Pegasus, some 290 million light years away. The picture also implies that a supermassive black hole is present in the center. It even shows stars coming into existence. The information will help us understand and reveal more about how galaxies form. The data will also tell us how fast supermassive black holes grow. It's been nearly 200 years since the invention of photography, when humans first succeeded in directly capturing and recording photons to create images. These days, vastly complex cameras that are on a space telescope 1 million miles away are quivering our understanding of the universe. They're opening new windows into space and time. These two incidents are separated by a relatively short amount of time, but they are connected by the same goal, and that is gaining a deeper knowledge of nature by gazing at what our eyes cannot see. And that's a wrap for this video. How much further do you think we'll be able to see into space? Let us know in the comments down below. Make sure to give this video a thumbs up and subscribe to our channel for more videos like this. Thanks for watching, and I'll see you in the next video.